This is a brand new section. Here we are going to talk about the recursion. Firstly, let's identify what recursion is. By definition, it's a way of solving a problem by having a function called itself. In computer science, it's a method of solving a problem where the problem depends on the solution to the similar instance of same problem. Such problems can generally be solved by iteration as well. The real life example for recursion can be a Russian nesting doll. Hopefully you have seen a set of Russian doll. If not, this is the picture of how it looks like. At first you just see one figure, usually painted wood, that looks like this. If you remove the top half of this doll, you will see another slightly smaller Russian doll inside it. You can remove this doll from here and again separate its top and bottom halves. Here again you will see another smaller doll. If you do it once more, you will see another smaller one. And we can keep going until we find the smallest Russian doll. It is just a one piece. So it does not open. As you see, Russian doll is a sequence of similar dolls inside each other that can be opened. But every time, size gets smaller and smaller. Each time you open a doll, a smaller version of doll will be inside it. And you repeat the process until you reach the final doll that cannot be opened. Here, if you think of these big dolls as a problem, you can see that the problem gets the small instance of same problem until we solve it. So this technique of making the problem smaller and smaller is called recursion. There are many properties of recursion. So let's see properties of recursion based on this real life example. So here our example of Russian doll conforms with the main properties of recursion. So the first property is performing the same operation multiple times with smaller input. So we perform this process of opening Russian dolls multiple times, and every time we open it with different size of dolls, which means that the input is different. So first we start from the bigger one, then they continue to which is smaller, then again we open the smaller one, and this continue like this. So here we open 10 different size of Russian dolls. As you notice that the process of opening all the dolls are same. That's why in the property of recursion, it says the same operation is being performed. So our operation here was opening Russian dolls. Now the second property of recursion is in every step, we try smaller inputs to make the problem smaller. Similarly, in the case of opening the Russian dolls, we try to make the problem smaller. And so, now you might be interested, why are we making the problem smaller? Because every time we make the problem smaller, this makes it easier to find the solution at the end, which is the smallest Russian doll at the end. That does not contain another one. This is the solution for this problem. Finally, the last property of recursion is that base condition is needed to stop recursion. Otherwise, infinite loop will occur. Basically, the base condition is the condition after that we will not do any more recursion. We will stop the recursion because we either would have found the answer or the answer does not exist. In the case of Russian dolls, we opened the first one, then the second one, then the third one, until we reach to this one, which is the smallest one. So we have to mention when we reach the smallest one that cannot be opened. We need to stop here. We need to stop here. Now you might be interested, what if we don't provide the base condition? In this case, this system will not know when to stop recursion, and this will lead to infinite loop. So no one wants to get inside an infinite loop because you never come out of it. There are even a lot of programming jokes about infinite loop. One that I like most is a programmer's wife. Tell him as he leaves the house while you are out, buy some milk. He never returns home and the universe runs out of milk. You see that she hasn't provided the base condition here. That's why her husband is gone forever. So hopefully you understand all properties of recursion. So let's convert this Russian doll example into the code so we can express it in the computer science. So our code for this Russian doll example will be like this. Here we provide base condition as when the doll equals 1. So all dolls are open when this base condition is reached. So here I took as a 1. The smallest one which cannot be opened, otherwise every time they are calling the same function with one smaller and opening each doll. So let's recap what we have learned here. So here we have learned that by definition, recursion is a way of solving problem by having a function to call itself. And we provided a real example of Russian dolls, which makes understanding the logic of recursion easy. So that's all for this lecture. Hopefully you understand the logic behind the recursion. In case you still have problem understanding the recursion, you don't need to worry about this because we will talk about it in a lot more details in the next section. See you there. Keep learning, keep smiling.